Hello, I welcome you all. The problem reads, if the motor exerts a constant force of 300 newtons on the cable, determine the speed of the 20 kg crate when it starts, when it travels displacement, or when it travels a distance of 10 meters up the plane starting from rest. The coefficient of kinetic friction within the crate and the plane is 0.3. This problem is coming from the Engineering Mechanics and Dynamics of 14th edition by R.C. Hibbeler. Right, so we are going to solve this particular problem using the two methods. Remember, we solved a similar problem like this in the previous video, and in here we are going to put all the two methods. We'll put the first method that we already dealt with and the second method. So let's draw the free body diagram. So we do have the weight. We have the weight of this box like so, and we have components. We have one component in this direction. It's not very visible. Let me use the weight. I mean the weight. I use this color, right? And then we do have two components. We have one in this direction and another one in this direction. Okay, and then we do have the normal force. We have this is going upwards, therefore we'll have friction in this direction like so, and the normal force in this direction. Then if we are to section this, let's say we section it somewhere there. Then we'll have tension here. We'll have tension like so. Okay. So let's call this T. We call this T. And this tension is constant. So it means and this is W. Right? And this angle here. This angle here is theta. And if this is theta, we also know that this angle here is theta, right? So if this is theta, so this angle here is theta, and this one, if that is theta, this becomes 90 minus theta, and therefore this is theta, right? So this is theta. So this becomes W cos theta, and this one becomes W sin theta, right? And this is the normal force as a normal force, and this is friction, which is just equal to mu k n. So like we said, we're going to use two methods. Let's just start with the first one. So the first one, we're going to call it method 1. Method 1, and in this method, we're saying, of course, we are using the equations of motion and kinematics. Right, there we go. So what do we have? Let's define what we have. So motion is in this direction, right? And we're going to call this as our AX. So let's find what Fk is. So I'll say summation of forces in the y equal to MAY, but we know there is no motion along the y direction is equal to 0. Therefore, we do have N minus W cos theta equal to 0. And our N is just going to be equal to W cos theta, which is just equal to mg cos theta. And Fk is just equal to mu k N, which is just equal to mu k, which is just equal to mu k mg cos theta. Right, so let's apply here the summation of forces in the x direction, which is just equal to mx. We know that t is constant, and therefore we expect ax to be constant also. Okay, to be constant, right? From the equation F equal to max. So summation of forces in the x, we do have T minus W sine theta minus Fk equal to max. So writing this, we have mg sine theta minus mu k mg cos theta equal to ma, like so. And then this is just going to be equal to T minus mg sine theta minus mu k mg cos theta divided by m. Okay, so we have all these values. So our ax therefore is just going to be equal to 300 minus 20 times 9.81. We can cancel out some stuff here, right? Let's do so. If we did cancel out some stuff, so this and this and this, and then what we remain with is ax equal to t divided by m minus g sine theta minus mu k g cos theta. So this is equal to 300 divided by 20, 9.8 sine 30.3 by 9.81 cos 30. Alright, so we have 300 divided by 20 minus 9.81 sine 30 minus 0.3 by 9.81 cos 30. Alright, so this we get ax is just going to be equal to 7.55 meters per second squared, and this we said is constant. Okay, because motor exerts a constant force. So let's use this equation to find our final velocity after the box is moved, cover the displacement of 10 meters. Okay, V naught squared 2a s minus s naught. V naught is just equal to 0, s naught is equal to 0, a is just equal to ax, which is equal to 7.55. What else? And s is equal to 10. Therefore, v squared is just going to be equal to 0 plus 2 times 7.55 then times 10 minus 0. Applying the square roots on both sides, so we have square roots this side and the square root this side. Therefore, we have our v, which is just equal to v2, and this is equal to 7.55 by 2 by 10. So 2 by 7.55 by 10, and square root of that, we have 12.29 meters per second, and our speed is in that direction, like so. Right, 2 by 7.55 by 10, square root of that is 12.29. Right. So let's now use another method, and this method we are calling it method 2, and this one is the principle. See, the principle of work and energy. Okay, so there we go. The principle of work and energy. Right. So what is this principle of work and energy? So the network is just equal to the change in the kinetic energy, and the change in the kinetic energy is just equal to half m v2, which is just the final, this is the final kinetic energy, okay, minus the initial kinetic energy, okay, which also can be written as T2 minus T1. These are T's, okay, and network, okay, is just equal to the summation of the total work from point 1 to point 2. Okay, and work done, okay, is just equal to the force times the displacement times the cosine theta between the two vectors, that is the force itself and the displacement. Right, for T and S, theta is just equal to 0 degrees. For FK and S, theta is equal to 180 degrees, right? And for W sine theta and S, theta is just equal to 180 degrees. And we know that cos 0 is just equal to 1, and cos 180 is equal to minus 1. So summing up these into our equation, we have t, we do have t times s minus fk times s minus w sine theta times s. Okay, and this is just equal to 1/2 mv2 squared minus 1/2 mv1 squared. So we know this part is 0 because v1 is equal to v0, which is just equal to 0. Right. What do we have? So our v squared, can it fit here? Our v squared is just equal to, let me just bring it down a little bit. Our v squared is equal to ts minus fks minus w sine theta times s divided by half m, and we can square both sides, right? Okay, like so. Therefore, now let's plug in numbers. So say our v squared is just equal to, our t is just 300 times 10, which is the displacement, minus we move it a little bit down, right? Just a bit down. Okay, and then this one we have 0.3, the coefficient of kinetic friction, the mass, times 9.81, then cosine 30, then times the displacement 10, then minus 20 by 9.81 sine 30 times the displacement 10, then divided by 1/2 times 20. Right, so we are dividing this like that, and then we square again both sides like we did. Right, like so. Okay, maybe we bring it down just a little bit. Maybe it is too much down, maybe up to there, like so. Therefore, we can now simply say our v is just equal to v2, which is just equal to 300 times 10 minus 0.3 times 20 by 9.81 cos 30 times 10 minus 20 by 9.81 sine 30 by 10, then divided by 0.5 by 20, then square root of that. We have 12.29 meters per second, and this in this direction, like so. Right, I guess we are done. Let's just outline the solutions. So in this we use two methods. It's really up to you, or it's really up to the examiner to tell you which method to use. If it's open, then you can use whichever method you feel can be applied, right? So I guess we are done, and I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.